Okay, once again, afternoon, folks. This time around, I'm coming with a Form 2 lesson, and this one is centered around factorization. But our interest is to learn how we can factorize larger expressions. And when we say large expressions, these are expressions sometimes which consist of uh, four or more terms. We want to check how the procedures are done. Now, the methods that we are going to be using, mainly when we are factoring a common term, would look at the biggest common value. But when we go to the variables or letters which are unknown, if they appear on two or more terms, it means they are common. So when we look at their exponents or their powers, the highest common will be carrying the lower power when we do a comparison on all the common variables. We are interested in the lowest power, and we are going to see how this works. So I'll be taking you through some basic problems here, and they will illustrate what I've been explaining just now. Let me try pick my pen here. Um, let's see. So the first problem that we have, if we have to inspect our terms, I've got 6x there plus 9. So first thing first, we put our equal sign there. Then we'll compare numbers alone, 6 and 9. Since both are multiples of 3, then 3 becomes our HCF. Then we are going to say, okay, so 3, we factor it out. Then we compare the letters of variables. We only see x on the first term, implying that it's not common. So we can open our bracket. What then do we do with the 3? We are going to use the 3 to divide both terms, and the result will go inside the bracket. So we'll do it step by step, like with the first term, 6x, we are going to divide it by 3. The result will be 2x. Then we have a positive sign or addition there. We do the same for the second, 9 divided by 3, it gives us 3. Then I close the bracket. As simple as that will be done with the first problem. Let me move to the second one using similar steps. Again, I'm going to do it step by step, but this time around it looks slightly different. I've got 14 and 7, and if I check those two values, they are both multiples of 7. So I'm going to put 7, which becomes our HCF. Then I move on to the variable y. If we check y is common on both terms, then I will then do a comparison. There is a 2, and on the second term, the exponent is 1, hence we don't write it. So if I compare 2 and 1, 1 becomes our highest common factor. So I'll say 7y, because we agreed that on the variables, the one with the lower power becomes our HCF. So since we are done, I will then open the bracket to say each term can I divide it by our highest common factor 7y. So if I say 14y squared divided by 7y, that will give me 2y. Then I move to the second one, but there's a subtraction sign. If I say 7y divided by 7y, I get 1. I think we have simplified or factored completely. I'm now moving to the next one, which is a bit interesting as well. I'm going to put my equal sign here. I've got 4a cubed plus 20a squared. So I will start by comparing 4 and 20. I'm interested in the highest common factor, but if I look at both of them are multiples of 4, implying 4 will be our HCF there. So I'll write 4. Then when I check on both terms, I have a, so a is common. And when I do the comparison of the exponents now, there is 3, there is 2, and we agree that the HCF will be the smaller power. Then I open the bracket. When I say 4a cubed divided by 4a squared, my result is going to be a. There is an addition sign, I also put a plus there. 20a squared divided by 4a squared, it's clear that the a's will cancel. We end up having 20 divided by 4, which will be a 5. Think that will be our solution for that problem. We're still continuing. We move to the next one. I have got x squared plus 5x. So I have variables, but remember, imaginarily there's a number there. And if the number is 1, we don't write it. So we do it step by step again. Let me put it in red that I have a 1. So we'll make a comparison. 1 and 5, they are both multiples of 1. But now, it means 1 becomes HCF. And when it's 1, we agreed we don't write it. So we'll directly move to the variable x squared, where x is common. Then we are going to say x here. We are now going to do a comparison of the exponents or the powers. I have 2 and 1 there. So the smaller one is 1, hence we won't write it. Then I'll open my bracket to say, let me divide both terms. If I say x squared divided by x, it gives me x. There is a plus. If I say 5x divided by 5, by x, I mean it will give me 5. I'm done with that. So I'm moving to the next one, number 5, where I'm interested this time around in factorizing by grouping. So in this method, we'll be discussing along the way, and we'll see if the method helps us in the subsequent ones. Um, I'll highlight the first two because we are factorizing by grouping. So that's my first grouping. And because I'm interested in grouping them in sets of two terms. So looking at the first part, we're going to say equal to. I'll do the same like I was doing before. 2 and 4, the HCF is 2. M and N, there's no common item there. So when I divide 2M by 2, my result is M. When I divide 4N by 2, my result is 2N. Close my brackets. Now I'm on the underlined terms. I'm trying to check between these two. It looks like the common term there is only x. Then I'll open my bracket to try and divide mx by x. It will give me m plus. If I divide 2nx by x, the x's will cancel. I remain with 2n. Then the procedure says, if I inspect what's inside the brackets and I realize that it's exactly the same, then I'll be allowed to build two brackets where what was common, it gets into the second bracket because it's common on both parties. It's like we are factoring it out. So I'll put m plus 2n. And what remains, 2 and x, they're supposed to get in the first bracket. So if I put them in, they are going to be 2 plus x. No, we don't write it as 2 plus x in math. In math, what starts is the variable followed by the constant or number. So I'll be forced to reverse and say here I'll have x and plus 2. That will be our result when we factor by grouping. Still moving to the next one. And I hope if we repeat the process here, it will make a bit of sense. That will say equal to, I'm treating the numbers themselves, 7 and 14, HCF is going to be 7 because 7 is common. So 7, I've got variables A and B, nothing is common, I then open my bracket. Now 7A divided by 7, it gives me A plus 14B divided by 7, it will give me 2B. Then I close brackets. I now move to the underlined terms. So I've got 3 and 6. So the HCF, because they are both multiples of 3, is going to be 3. And I look at the variables. I have AC and BC, or C is common. Then I open bracket. If I say 3AC divided by 3C, the result is A plus. If I say 6BC divided by 3C, well, 6 divided by 3 gives us 2. The C's will cancel and I remain with B. Then I'll test to say, inside the brackets, do I have the same term? Looks like it's the same. Then I'll proceed to open two brackets where the common terms that I saw, which I'll factor, I'll put them inside the second bracket. Then what remains is 7 and plus 3c. And we agreed that we start with 3c, then plus 7. I think that's it on the sixth example or problem. I'm moving to the seventh. Factorize by grouping. Again, we are repeating the same. Here, I'm having 10 and 5. So clearly 5 becomes my HCF. The P and Q are not related. So I'll be forced to open bracket and say 10P divided by 5, it gives me 2P. Then on the second part, minus 5Q divided by 5, it gives me minus Q. Right, we check the second part where we have underlined items 8 and 4. Well, the HCF there is going to be 4. So let's say plus 4 there. Then we have got PR and QR. So we'll need an R to be factored because it's common. Then we'll open a bracket and now start our process. 8PR divided by 4R. So as good as 8 divided by 4, it will give us a 2. Then the R's, they will cancel and remain with P. We do the same for the second term. If we divide, well, there's a negative there, we put a negative. Then we divide 4 by 4, gives us a 1. The R's here will cancel, will remain with Q. Then we move on to say, is what's inside the bracket the same? Yes, it is the same. Then I'm going to open first bracket. I put 2p minus q, and even, oh, in the, sorry about this, in the um, first bracket, like we agreed earlier, we are going to do uh, a check. There is 5 days plus 4r, but what starts inside is going to be 4r plus 5. Still proceeding, show to the last problem. We are going to now test the first two. We are going to say 9 and 12. What's our HCF? Now, this time around, these are not multiples of each other, but both are multiples of 3. So 3 becomes the HCF. And when I look at the variables, it's x and y, nothing is common. So I'm going to say 3 here. Then when I divide 9x by 3, it will give me 3x. When I divide 12y by 3, it will give me plus 4y. Then I close my bracket. I'm now moving to the underlined items. Where I've got 3 and 4, there is no HCF there other than 1. And we agreed when it's 1, we don't write it. There is x, z, there is y, z. And we'll see that is z which is common. Then I'll open my bracket. Now, next I'm going to divide 3xz by z. So the z's will cancel and I remain with 3x. Then there's a plus there. When I divide 4yz by z, the z's will cancel again and I remain with 4y. Then we will do our inspection to see what's inside the brackets. Is it the same? And then I'll be forced to build two brackets. And what's common, it gets into the second bracket. And in the first bracket, let's do it this way so that it's clear that that's our z. It's z which will start first plus 3. Think that will be it. I hope you guys you found this interesting. We'll meet in the next recording. Please don't hesitate to comment on the comment section below so that we improve on the areas that you might find gray. Thank you.